All right, hey guys, it's Miss Leslie and Miss Mark here with day 16. We're doing an intro to combinatorics, which we talked a little bit about during our live stream, but we're going to get into more today and obviously the rest of the week. It should be a pretty okay week. It's kind of new, but the concepts aren't that challenging, so hopefully you guys will enjoy this week. This is going to be our last week of new notes for this unit. Next week, we are going to kind of review all the different things we've talked about, like sequences and series, factorials, binomial theorem, and then this week. And so next week on Friday, your checkpoint will be kind of like a test, right? It's going to be everything from the whole unit. All right, so this is really our last week of new stuff, right? And then we kind of wrap up the unit next week. But yeah, so I will let Miss Marker take it away so she can tell you guys about the fundamental principle of counting.
Yeah. So yeah, hopefully this week is kind of a nice break. I feel like the last couple weeks have been a little bit, not hard, but not super easy. So hopefully this is better. So yeah, today we're just doing the fundamental principle of counting. It shouldn't take you very long, and it shouldn't be too bad. If you guys have already looked at the homework today, that's going to be updated because I got what we were doing today mixed up a little bit. So just be aware that it's going to be a little bit shorter than it says on Schoology right now, but that's okay. We'll work with it. Okay, so the fundamental principle of counting is basically determining how many different outcomes you can have based on the number of possibilities you have. So say we have an event, and let's just call it E1, and if E1 can happen, that can happen M1 different ways. And if you have an event E2, that can happen M2 different ways. Okay, so what the fundamental principle of counting tells you, that is a mouthful, is that the number of ways that those two events can occur. So the number of ways that those two events can occur together is equal to M1 times M2. So essentially all you're doing is you're taking the number of different ways that event 1 can happen and the number of different ways that event 2 can happen, and you're multiplying them together. So say we want a combination of 2 letters of the alphabet. So if you have the first letter, that can happen 26 different ways because there's 26 different letters in the alphabet. And then we have the same event because it's 2 letters put together. So the other number of ways that event 2 can happen is also 26. So you would take 26 times 26, and that would give you 776 different ways that the 2 alphabets can go together. Yep. If that makes sense. It's not, it sounds kind of convoluted, but it's really not that bad. But yeah, so this would be like A or B A. I'm not gonna list them all out because there's 776 of them, and that would take way too long, but just know that that's what that is. Yeah. Cool. Okay, so then I have an example for you guys, and then I have the homework down below. I might go over maybe one of them, and then that's about it for today. So we have a fast food restaurant, and it has a meal special. So it's $5 for a drink, sandwich, side item, and dessert. So your choices for your sandwich are grilled chicken, a beef patty, a veggie burger, or a fish fillet. And then you have all these different options for your side, your dessert, and your drink. So what we're trying to answer is how many meal combinations are possible. So for this one, we need to find out the event, the number of ways that event 1 can happen. And the event 1 that we have here is your sandwich. So you have to choose which sandwich that you want. And the number of ways that you can, or the number of different options you have, there's 4. So this is going to be 4, and that's going to be M1. E2 would be what side you want. So M2 would equal 3, because you have 3 different options there. You have regular fries, cheesy fries, or potato wedges. Event 3 would be your dessert, which you also have. Oh no, you have 2 options there. I just can't read. This is your dessert. So M3 would be 2 options. And then event 4 is what drink you want. And so M4 would equal 5. And then to figure out all the different ways that you can combine the meal and get different combinations, you would take all of those M events and you would multiply them together. So you would take M1 times M2 times M3 times M4. So you would have 4 times 3 times 2 times 5. And so you have 120 different ways that you can make your meal. That's about it. Anything to add, Miss Lastly?
No, that's good. Yeah, I mean, this was a great example. Really, you're just taking the number of combinations and you're just multiplying them to each other. This type of question, which I'm sure you're going to see on your homework, also like for this property can also be used for a couple different things. This is one really good example. Another question that comes up a lot is like, for instance, how many different ways or how many different telephone numbers can you make using different digits or something? So the same thing, like event 1, how many numbers can you pick from for the first number? Event 2 is how many numbers can you pick for the second number? So this whole technique is good for just finding the different number of combinations of anything. So just remember, this is one example, and you're going to see a few more different examples on your homework, but this can be applied to a lot of different topics. So the one hard part about this week is knowing which word problem should you use which technique for. It's really the hardest part.
Mm-hmm. Yep. License plates are a big one too.
Yeah,
phone numbers.
License plates, definitely.
Yeah. So yeah. That is about it. It's not super hard. Your homework's going to be really short today. Like I said, if you looked at it this morning, it's going to be updated again because I have some things on there that we're not talking about. So yeah.
Do we want to do one problem for their homework? I don't know how many problems are on there, but probably do one.
I have 6 on here. Yeah. Let's look at number 4. How many ways could you roll doubles?
Oh, that's a good one.
Okay. So on your first die, so remember this is a 6-sided die. So on your first die, when you roll it, you have 6 different options that you can. Ooh, that is way too thick. Die number 1 and die number 2. Okay, so say we rolled die number 1. We rolled die number 1 and we get a 6. For these to be doubles, you would have to get a 6 on die number 2 as well. So on die number 2, the only way, or sorry guys, I haven't had my coffee yet this morning, so my brain isn't working. There's only one possible outcome that you can get to roll a double because it has to match that first die. So this one would be 1. On that first die, you can get whichever number pops up. So there's 6 different ways that you can get that one. Like I said, because if you roll, say, a 5 on the first die, then you have to roll a 5 on that second die to get doubles. So you have 6 different options for that first die, but then once you roll that one, you have only one option on that second die. So the number of ways that this can happen is 6 different ways, because 6 times 1 is 6.
Yep. Cool. So that's the concept, guys. Sometimes you may find yourself overthinking with these. Please don't do that. Most of them are pretty straightforward. But yeah, that is it for today. Tomorrow we will be talking about another different way of doing combinations of things, but that's kind of the theme for the week. All right. Well, it's been great, but bye, guys.
Last thing, I might be a little late to office hours today. I have to help my mom. I have to take her to a doctor's appointment for her foot, but I will be on there answering questions at some point today.
Cool.
Yep.
All right. Bye, guys.